Hey everyone, this is Filip Rakowski, and behind me there is Geralt, my cat. I hope you won't be interrupting. And I just realized the title of my talk is quite long, so I made it a little bit shorter for you. So just to give you a quick introduction of actually who I am. I'm a co-founder and chief DX officer at Vue Storefront, and I will talk what Vue Storefront is in a moment. Some of you may know me also from other Vue.js events. So I have been building developer tools for 6 years now. More precisely, I'm building an ecosystem of developer tools that aims to simplify building e-commerce storefronts, and it is called Vue Storefront, which I hope at least part of you heard about, because it's not the first time I'm mentioning it at the event. Honestly, it's not even 20th. So anyway, one of the core promises of Vue Storefront is great performance. And it's not a nut, you will see that it will make sense. So we deliver a set of different tools to solve different problems that people would encounter while building e-commerce storefronts. And we have our own UI library of copy and pastable components. We have an integration layer with a lot of integrations done out of the box. We even have our own accelerators that basically have all the basic e-commerce functionalities included, and they are using Nuxt, or also Next. We even have our own cloud. And despite giving so much out of the box, we've been seeing the same problems for years. No matter how fast the accelerator is out of the box, no matter how great our tools are, and how many abstractions we will build to make things simpler, customers will always find a way to ruin the performance. So while out of the box Vue Storefront has a lot of features, scores great at Lighthouse, and is objectively fast and lightweight, the real production implementations usually look like this. And this talk is about our journey of understanding why this was constantly happening, the conclusions we came to, and the steps we took to prevent that from happening again, that I believe are quite universal for, like every Nuxt.js project. And the reason why I showed how great Vue Storefront performance is at the beginning was not to brag about it, not at all. Actually, I wanted to prove something opposite, that the initial performance of your Hello World project means nothing. So look, if Vue Storefront delivers 80% of the ready project, which is a lot, with 90 plus performance score, and most of the live projects score around 50, sometimes much less, tell me what is the point of comparing Hello World performance of Next or of Nuxt? As soon as you will install first 5 node modules, this number will be probably 5% of your application, like the Hello World one. So let's agree once for all, Hello World performance means nothing. If it's good. If it's bad, it means something, because it sets a hard limit on how good your application actually can be. But your final application performance will always be much worse than Hello World. And the footprint of the framework itself is kind of meaningless for the end result, because today all the modern meta frameworks score great out of the box, and the demos always look great, and drilling into tiny differences between Nuxt, Next, Astro on that surface, I think it is completely pointless, and just don't do this. So we already dealt with one misconception about front-end frameworks, but the fact that Hello World performance isn't important, it actually doesn't mean that the choice of a framework isn't important. In fact, I think the choice will have kind of huge influence on your application performance. If you're on Twitter or on X, which still sounds a little bit weird, you probably see pictures of great Lighthouse scores posted by adopters of modern meta framework like Astro or Qwik. And these are all valid pictures. And indeed, in general, Astro or Qwik applications are faster than Nuxt ones, but please listen to me, don't crucify me yet. Listen to me for the rest of the talk, because I'm in the Nuxt team, really. And first of all, there is a lot of additional context to this picture, like complexity of an average application in Astro versus Nuxt. But really, there are good reasons why applications built with those frameworks are actually fast. And it is not only it is not only because we are mostly building blocks with them. So both Astro and Qwik are very opinionated tools, focused on achieving great performance. And this is the main reason why they were created, and every decision that the creators made was kind of towards this simple goal, like achieving great performance. So these frameworks leave much less space for the developer to make decisions about certain architectural aspects of the application. Some of those decisions are just already made, and you naturally kind of like follow the patterns that creators of both frameworks established while building your application. Nuxt. Nuxt is also opinionated framework. But Nuxt is optimized for extensibility and actually ability to cover very wide range of different use cases. So doesn't mean you cannot achieve the same performance with Nuxt as you do with Astro and Quick. Are we doomed? Not at all. So Nuxt has everything you need to get there, and honestly it has much more, but it has different defaults than Astro or Quick, and people usually follow the defaults, and this is why you could get a perception that Astro or Quick are just faster. So you need to do a few extra steps to lay out proper foundations and follow the patterns that you established by yourself. So let's explore those patterns, let's explore those architectural decisions that actually makes this performance-oriented framework fast. And what is more important, let's learn how we can make use of them in Nuxt to make it as optimized for performance as they are. So we will set the right foundations, and we will put the rails with a few first commits that you can drive safely till the end of the project implementation, because the truth is all the patterns and all the decisions that you'll make at the beginning of your project, everyone else will follow them, and you will probably also follow them, because we like to keep our projects consistent. Like, this is also a best practice, right? To solve the same problems the same way. And I specifically choose Astro and Quick because they aim for different use cases, and I will be talking mostly about Astro because Quick actually just goes one step further, and Astro is more well suited for websites, Quick is more well suited for apps, and Nuxt is suited for both. So let's start with Astro, and I want to be honest. I personally think it is absolute revelation in the front-end framework space. They filled the gap in the market that was missing a meta framework that was aimed for lighter and simpler websites, but still delivering the developer experience of modern JavaScript tooling. In addition, Astro solves one of the key problems that websites built in modern frameworks suffered from, poor performance. And this poor performance was caused by huge chunks of JavaScript in the bundle. So let's decipher what makes Astro fast. Astro is a server-first, or actually static-first framework. So in opposite to most, or almost all other meta frameworks, it is implementing multi-page application architecture. You might never heard this term before, but multi-page application architecture is well known from the good old days before single-page applications, when we were sending HTML files over the wires with a sprinkle of jQuery code. Good old days. So Astro renders each page on the server and then sends it as a pure HTML. And this eliminates waiting for the initial HTML almost completely and delivers it to the browser as fast as possible. This can be easily achieved with Nuxt, with setting target static. And honestly, I think static size deployment should be a default for everything that is not specifically an application, and sometimes even for application. SSR, which is server-side rendering, is an overhaul. Of course, you can have great performance with SSR and very high cache hits ratio, but generally it's an overhaul, and static size are just much better. Server can always be a bottleneck under high traffic, server could cost a lot, server could unexpectedly die if you accidentally introduce a memory leak, which is actually quite common. So with static size, all of those problems just disappear. So the first good default that I would highly recommend is using static size instead of universal rendering with SSR. This approach just eliminates a whole class of problems. Another reason why Astro is fast is that it doesn't ship JavaScript with this HTML file. So it is static by default, and any dynamic interaction needs to be explicit. So once your Vue components are rendered as HTML on the server, they stay as HTML in the browser. If you want to make them dynamic or hydrate, and even include Vue.js into your bundle, you actually need to explicitly tell the framework to do this. So Astro calls this interactivity islands. In short, you explicitly mark components in your code that should be interactive and therefore you should should have their JavaScript code actually executed and downloaded. So unless you declare something as interactive, and here we have an example from React, but it works exactly the same with Vue.js. So unless you declare it as interactive, the static HTML will not contribute to the bundle. So even when you declare it, you have to explicitly say when to download the JavaScript code responsible for this interactivity. So here we see client load, which means we should download it immediately. But you can also do this on some interaction like click or focus. And I think this is the major difference between Nuxt and Astro. Astro is static by default and Nuxt is dynamic by default. And just to make things clear, there is no universally better approach, and each of them has their trade-offs. But if we are looking at this purely from the performance perspective, static by default is just a better approach that makes it much easier to achieve good front-end performance. And static here, I don't mean static site generation, but just static HTML. At the same time, Nuxt is a far more advanced tool than Astro, and it can fulfill many more use cases than that. And the fact that Nuxt does something by default does not mean that it does not provide a variety of tools and techniques to actually make it different. So how we can actually introduce this Node.js mindset from Astro in Nuxt, and what features do we have available? To be frank, there are a lot of them, and I will scratch only the ones that I really like and I think are most impactful, but there is a lot of them. So first, let's break down the ways we can introduce new JavaScript code to our Nuxt.js bundle, and then how we can prevent that. And the mental model here, at least from my perspective, is quite simple. Generally, there are only two main ways for a JavaScript code to enter our Nuxt.js bundle. Through a component, even if this is a composable, it ends up in the bundle only if it's being used in a particular component or a plugin, or through a plugin. And Nuxt injects plugin globally, and we should be very careful with actually adding anything in the plugins. Also, it is important to mention that Nuxt modules can also inject plugins, and they can be often a cause of performance bottlenecks. So unfortunately, there is not much we can do with those things. So the best way to prevent problems with Nuxt module is to build your project every time you install one and measure the performance impact. So if you're curious if your module is actually adding a plugin, just jump into the repo of this plugin on GitHub and search for add plugin phrase. This is how we learn. And then you can jump into this plugin, see maybe it is adding some third-party dependencies, maybe it's not. Also, measuring often is another foundation and actually usage pattern that you should implement no matter what software you are using. So framework authors can do a great job, but they don't control the ecosystem. So a poorly rewritten plugin can be a bottleneck even in Astro. So every time you add a third-party dependency, it's a good practice to just run Nuxi, analyze, and see the impact. So this will show you a very nice visual representation of your dependencies. It's pretty much like Webpack Bundle Analyzer, but for Nuxt free. I hope some of you at least know Webpack Bundle Analyzer. So coming back to our bundle contributions. When it comes to components, they can be rendered in three ways. So we have two contributors, now components that can be rendered in three ways. They can be rendered as server-only components. And Nuxt has an experimental feature called server components, which I think is an absolute breakthrough for web performance. They are quite easy to understand. In short, Nuxt server components render only once on the server. So once they arrive on the client side, they don't include any code in the front-end bundle. So it's pretty much like it happens in Astro by default. And in Nuxt it is also called islands, but this time it is an opposite approach. So in Astro we have islands of interactivity, and here we have islands of non-interactivity. So my recommendation would be to think server components first as a good default. Even though Nuxt is not enforcing it on us, we can enforce it on ourselves. So this way you introduce new code to your bundle consciously and you're not surprised. Using component islands, or how I prefer to call them, server components in Nuxt, is that simple. First, we need to enable them in Nuxt config because it is still an experimental feature. Then you just add that server extension to your component, and that's literally it. That's all. Then you just use it like a regular component. But not all components can be purely static. Sometimes they need some interactivity. Sometimes it can be handled with CSS. And honestly, if this is like a visual interactivity, you should handle it with a CSS, because even like tiny open close mechanism requires you to download the whole VDOM of the component as JavaScript file. Though, even if this component really needs interactivity, there are clever ways of adding this interactivity. We never should add interactivity up front. You always need it on certain conditions. And those conditions could be on a click, on a hover, or when something is below default, when elements enters the viewport. So we can also delay JavaScript code execution until that moment, just like Astro does, as we have seen. And there is a great library made by Jacob Andrzejewski, who works at Vue Storefront actually, and who also had a talk at this event yesterday. This library is inspired by other library, which is Vue Free Lazy Hydration, and this library is inspired on other library, which is called Vue Lazy Hydration by Markus Oberlachner. So he is like the father of this idea, but you know, enough about credits, though you should give them. This library brings a lazy hydrate component to Nuxt that allows just this, lazy loading interactivity. So just use this component, wrap it around the things that you want to make dynamic lazily, and it will download and execute the chunk of JavaScript code responsible for it at the right time. This is exactly how it works in Astro actually. So if we treat server components by default and hydrate dynamic ones on demand, we have a very similar approach, and we can expect actually very similar results. And in Quick, we have something called Optimizer, and it is even simpler because Optimizer in Quick does everything that I just mentioned automatically. This is something that Nuxt and Vue can't match yet, but I hope at some point they will. So enough theory, because I talked a lot about theory, but at the same time, I really believe that it's very important to understand some concepts, and I really believe that if you understand the underlying motivations behind something, then you don't need those charts, you will just know what to do. So you already understand the problem well, so let me give you a pattern to solve it once and for all. So this is a decision tree that we personally advise our customers to follow. And by default, we treat all components as server ones, and think twice if we really need interactivity. Probably most of the components in your application can be server ones. But okay, if this is visual interactivity, think about CSS. If this is a data interactivity, then we need to think if the element needs to be interactive immediately or on a certain interaction. If it's an interaction, we can use lazy hydration. Now, even if an element needs to be interactive immediately, it's often below the screen. So in that case, we can still use lazy hydrate with a one visible rule for this lazy hydration component. So the only case when you'd like to download the JavaScript chunk of a component and execute it immediately is when all of those questions we are answering, well, the first we are answering yes, but the rest we are answering no. Now let's talk about plugins. So while we'll use components to include some one-off libraries, so we often include a library inside a component, plugins are usually used to deliver certain functionalities to the whole application. And this can often become a bottleneck because they also execute eagerly. So is there a more performance-friendly way of delivering, a certain functionality across your whole application? Well, of course it is. It's Nuxt. So everything is possible here. It's a river of performance possibilities. So exactly the same way you're actually declaring server-only components, you can declare server-only plugins. Just add server suffix to the file name and the plugin will be executed only in a certain environment, which is server or client, but I suggest server. Though if you want to make use of this plugin in server-only components, you have to make sure to set the islands property to true. Probably mostly because it's experimental. I don't know yet, but probably once it's gonna be a stable feature, it will just work. At least I hope. So the decision tree here is much simpler. I would say if you don't see a use case for a plugin in dynamic components immediately, make it a server one. You can always change it in the future, and actually that would also apply for components by just changing the file name. So you don't need to refactor. You can just simply change the file name. And you already have two powerful frameworks to follow, but there is one more thing I'd like to just mention, and it's the data. Or to be more precise, how we fetch it and how we transform it. So a lot of code in modern front-end applications is doing data transformations. I think this approach is kind of wrong, because really, if you think about the front-end should just receive data in the form that is as easy as possible to display. So data transformation libraries or SDKs from different vendors that fetch the data or transform it, they can be super heavy, really. So ideally, you should avoid putting them on the front end. And in Nuxt you have a concept of API routes. What is API route? API route is a server-side API that is binded to your Nuxt.js application. So this code runs entirely on a server. So instead of adding an expensive SDK to your code base, just consider fetching the data in this API route on the server or transforming it using data transformation libraries and then send it to the front end. So there you just only need to display it. And this way you can save a lot of kilobytes of JavaScript. And this is just another tool that Nuxt gives you to think server first. So thank you so much. I hope you learned something, or maybe you embrace a different mindset, a server first and Node.js mindset, and enjoy the rest of the talks. Thank you so much.
Thank you, Philip. This was wonderful. Now, let's take a look at these Q&As. All right, so to start, how do I introduce this concept to my team, especially my boss?
Okay, it is actually a common question, and it's a very good question because at least for developers, it is quite hard to sell performance to their bosses, but the thing is, performance sells. There's a dozen of statistics showing how performance improvements can actually increase the revenue. And there is a website, WPO, which is an acronym for Web Performance Optimization Stats.com. If you go there, you will see a lot of numbers proving that it is just worth. So, if you're talking to your boss, ideally talk to them with the language of money. And this is something they will understand.
Wonderful, thank you. All right, next question. Do you have a technique for naming your commits? A junior developer would like to know. I would like to know because my update, forgot a space, update is probably not the best way to name commits.
Honestly, I would like to know as well, but luckily in our company, our teams embrace something that is called conventional commits. So you can Google that, and it is actually a great way of naming your commits. There are even CI/CD tools that are checking that. So this is the right way. Though right now I have admin access on GitHub, so sometimes I'm bypassing it as well. I'm guilty.
Thank you. All right, last question. In Git, is it always advisable to create a new branch for every change or feature?
We would need to start a war in here if I would give my opinion. But a general good practice is yes, you should do this. But if someone tells you not to do this, just don't do this, don't argue, because it could be risky and it could be very, very bad for you.
All right. Good to know. And thank you, Filip, for joining today. We greatly appreciate it.
Thank you.